In a lot of ways, we're doing stuff that hasn't been done before, bringing a product like this onto the water. So the closed-loop coolant system is a great example of that, of really rethinking what it means to do a marine coolant system. I'm Matt. I lead the mechanical systems engineering team here at ARC. The team is responsible for a lot of the onboard systems that make the boat work. That includes things like battery mechanical design, driveline, dynamic systems like steering, and then also the fluid systems like the cooling system.
My name is Jay. I'm an engineer on the mechanical systems team here at ARC. I work on the cooling system, which basically ensures the boat is safe and operating smoothly, especially when things get really hot inside the boat. Cooling is critical to electric boats because there's so much heat that is generated from motors, inverters, batteries, chargers, and all the electronics. And each of these components, they need to stay within a certain temperature range in order to achieve their full performance.
So traditional gas boats use what's called an open loop cooling system. Essentially, they bring in water from outside the vehicle on board in order to exchange heat, and then they move that water back off the vehicle.
The challenge here, though, is that raw water also brings in salt, sand, debris, and that leads to corrosion and higher maintenance over time. From clogging to corrosion to yearly winterization during the off-season, owners end up spending most of their time maintaining the boat rather than actually enjoying it.
So the way the closed-loop cooling system works is it's one big, simple loop that goes through all of our components. The coolant travels through all of those. It accumulates heat as it goes, it rises in temperature, and then it goes through the cold plates that are on the back of our boat near the transom. Those are being always cooled by the lake around it. That brings down the temperature, and then the process repeats from there. So this plate goes into a recess right here, and so it actually sits inside of it, and that's specifically designed just for this plate. So heat conducts through convection onto the surface here, conducts through and then convects again to the lake around it.
It's meant to be something that works in the background and is not something that you have to have that maintenance and checklist headache about every time you're going on the water. It allows you to basically be hands-off and just monitor to make sure that your coolant system is topped off and that the system is working properly. When you're thinking about going electric, it's not actually a trade-off between performance and reliability. You're actually getting a boat that is simpler to own, quieter to use, and more performant.
I think if you want a cleaner, quieter, and more user-centric experience, then you should make the switch.
What gets me stoked about working at ARC is truly the people that I'm working with. Everyone here is motivated by this one mission to electrify everything on the water and make the planet cleaner. When we have clean water, we have clean air, and when we are disturbing the wildlife less, we're able to have a more natural connection with the environment.